Okay, in this section of the logarithms tutorial, you will learn how to use logarithms to solve math problems involving pH. In front of that, you'll learn a very quick introduction into what is pH, what's it mean in chemistry, and why is it of interest to chemists and scientists and mathematicians. pH is the negative base 10 logarithm of the hydronium ion concentration in a fluid measured in moles per liter. If that sounds like a mouthful, it is. Hydronium ion concentration is normally expressed as H3O plus wrapped in square brackets. And pH is the negative base 10 logarithm of the hydronium ion concentration in a fluid. pH is an exponent. It's a value between 0 and 14, indicating the acidity of a fluid. Values less than 7 indicate a fluid is acidic. Values greater than 7 indicate a fluid is basic. And a pH of 7 means the solution is acid neutral. pH is of interest to chemists because water has a natural tendency to autoionize, meaning it throws off hydrogen ions, producing hydronium ions that are positively charged and hydroxide ions that are negatively charged. Greater concentrations of an impurity in water triggers more autoionization. The more pure the water, the lower the ion concentration. Adding an acid to pure water disturbs the equilibrium and will raise the hydronium concentration. So in a neutral solution, the concentration of hydronium is about equal to the concentration of hydroxide. In an acidic solution, the concentration of hydronium will exceed the concentration of hydroxide, giving a pH greater than 7. And in a basic solution, the concentration of hydroxide is greater than the concentration of hydronium, giving a pH of less than 7. So pure water is said to be pH neutral, and in it the hydronium and hydroxide concentrations are equal and probably measure about 1.0 times 10 to the negative 7 moles per liter. The negative base 10 logarithm of 10 to the minus 7 is 7. pH is the negative base 10 logarithm of the hydronium ion concentration in a fluid. There are two key equations to understand and work with when solving math problems involving pH. The first is pH is the negative base 10 logarithm of the hydronium ion concentration. The problems that you see will either furnish a pH value and say what's the hydronium ion concentration, or the problem will furnish a hydronium ion concentration value and ask you to compute the pH. So knowing how to convert between these two key equations is important to understand in solving math problems involving logarithms and pH. So the question is, how does this expression get converted to this expression? pH is the negative base 10 logarithm of the hydronium ion concentration in a fluid, typically water. Multiply both sides times -1 to shift the negative sign to the opposing side. The next step involves application of the fourth property of logarithms that you first learned in the introduction to this tutorial. And that property says that 10 raised to the power of a base 10 logarithm of some number is that number. And in the example that you saw in properties, 10 raised to the power of the base 10 logarithm of 23 is 23. So going from this expression to this expression, simply take 10 to the power of that value is equal to 10 to the power of that value. So minus pH is equal to the log of the hydronium ion concentration. 10 to the value, to the power of negative pH is equal to 10 to the power of the log of the hydronium ion concentration. 10 to the base 10 raised to the power of the base 10 logarithm of something is that something. So we have the hydronium ion concentration is equal to 10 raised to the power of the negative pH. So that's how to convert back and forth between these two expressions. And these two expressions are the key equations to understand and know how to use when solving math problems involving pH. There are 5 example problems in this tutorial, all of them involving one or both of these expressions, and they are the next part of this tutorial.